You have written a query. It worked fine in dev. You ship it to production. Suddenly, your app is slow. Page takes forever to load. Users start complaining. You stare at the SQL. The query is simple. The data is fine. Why is everything broken? 9 times out of 10, the answer is same. You forgot an index. And in the next 10 minutes, I am going to show you exactly what an index is. Why one tiny addition can turn a 10-second query into a 1 millisecond query, and why adding too many of them can quietly destroy your write performance. This is the single most useful database concept I can teach you. Most beginners skip it. Senior engineer obsess over it. Let's get into it. Here's the one sentence answer. An index is an extra data structure that a database keeps next to your table, sorted by some column, so it can find things without scanning every row. Read that again. Extra data structure sorted next to your table without scanning every row. Let me unpack it. Your actual table is just a rows in the order they got inserted. Row 1, row 2, row 3. If you ask the database to find every user whose email is ravi@example.com and there is no index, the database has nothing clever to do. It reads every row one by one. 10 million rows means 10 million checks. That's a full table scan, and it's the source of most slow query problems. An index changes that. When you create an index on an email column, the database builds a second structure on the side, a sorted copy of emails, each pointing back to the row it came from. Now, instead of scanning 10 million rows, the database can binary search its way down through the sorted index in a handful of steps. 20 something jumps instead of 10 million. Stick this in your brain forever. The table holds your data. The index holds the shortcuts. That's the whole idea. Everything else is just details about what kind of shortcut and how it's built. Here's a picture that's going to stick. Think about a textbook. A real physical textbook. 500 pages on biology. You want to find every page that mentions photosynthesis. Without an index, you have got one option. Open page 1, read it. Open page 2, read it, keep going. 500 pages of reading just to find a word. But every real textbook has something at the back. A list sorted alphabetically that says photosynthesis. Pages 247, 312, 408. You flip to the back, you find the word, you jump straight to that page. That little list at the back of the book is a database index, word for word, same idea, same purpose, same trade-off, which we will get to. Now here's where it gets clever. What if the index at the back of the textbook was itself 5,000 entries long? You would be scanning the index. That's not much better. So in real database, the index isn't a one flat list. It's a tree, a sorted tree, where the top level says everything under M is on the left, everything from M onward is on the right. You pick a side, walk one level down, and now it says everything from M to P is on left, P to S is on right. Pick again, walk down again. That tree is called B tree. And it's the structure inside almost every database index you will ever use. Each step roughly halves the search space. With about 23 steps, you can find one row in 10 million. With 30 steps, you can find one row in billion. There are 3 reasons indexes matter, and you should care about all of them. Reason 1, speed. We just covered this. Scanning a million rows versus looking up one row isn't a bit faster. It's often 1,000 times faster. The difference between a page loading in 100 milliseconds and a page timing out. Reason 2, survival under load. A single slow query under a load doesn't just slow down, it piles up. Every new request waits behind the slow one. Connection fills up. The database starts queuing. Your whole app falls over because of one missing index. I have seen this take down real production system more than once. Reason 3, interview reality. Every backend interview asks about indexes. If you can explain why a query is slow, identify the missing index. and describe the trade-off of adding one. You are already in the top tier of candidates. Most people memorize the word index and stop there. Okay, let's look at the structure that does all this magic. First, here is why an index matters at all. Same query on the left and the right. On the left, no index. The database checks every single row. On the right, with the index, it goes to a sorted list, finds the email, follows a pointer to the exact row. 2000 milliseconds become 1 millisecond. That's a real measurable difference, and it's happening on every page load of every app you have ever used. Now let's open up that sorted list and see what's actually inside. This is a B tree. 3 level. The top level is called the root. It holds rough ranges, everything less than 3 million. 3 to 6 million, more than 6 million. You pick the right range, one read. The middle level is called the branch level. Each branch node holds a tighter range within the parent's range. 3 to 4 million, 4 to 5 million, 5 to 6 million. You pick again one more read. The bottom level is the leaves. The leaves hold the actual sorted key values and a pointer to the row in the table. One last read and you have your row. 3 reads total. To find one record among 10 million, not because the database is fast, but because the structure is smart. And here's the part that blows most engineers' mind. Even if your table grows from 10 million rows to 100 million rows, the B tree just adds one more level. 3 reads become 4. The whole point of B tree is that the depth grows logarithmically, meaning it almost doesn't grow at all. One more thing, indexes can be on more than one column. A composite index on email and created at lets you efficiently search by both at once, but the order matters. An index on email then created at is great for searching email first. It's useless for searching created at first. The tree is sorted left to right. I want to be honest with you about something most courses won't tell you. Indexes are not free. The good news, a well-placed index can turn a dying query into a fast one with zero application changes. One line of SQL. The bad news, every index you add is another structure the database has to keep updated on every write. Insert a new row, every index has to add a new entry. Update a column, every index touching that column has to be updated. Delete a row, every index has to forget about it. So if your user table has 10 indexes on it, every insert is actually 10 plus 1 write onto the table. 10 to the indexes. You write, throughput drops. Your disk usage climb. Your backups get bigger. This is the trade-off nobody warns you about. New engineers either add 0 indexes and wonder why everything is slow, and they add an index on every column and wonder why writes are slow. Now, when not to add an index? When the column is rarely queried, when the table is tiny, when the column changes constantly, when the write load already dominates the read load. Every component you add is also a thing that can slow you down. Simplicity is the feature. 4 questions this video has set you up to answer in interviews. Question 1. What is the database index in one sentence? A sorted site structure the database maintains alongside the table so it can find rows without scanning all of them. Question 2. How does B tree make lookup fast? Each level of the tree narrows the search space by a big factor. 3 or 4 levels is enough to find one row in millions. That's logarithmic search complexity in action. Question 3. Why can adding indexes slow down your application? Because every index has to be updated on every write. More indexes means more work per insert, updates and delete. Read heavy workloads benefit, write heavy workloads suffer. Question 4. How do you decide which column to index? Index columns that appear in where clauses, join conditions and order by clauses, especially when the table is large and the column has a high selectivity, meaning lot of distinct values. Don't index columns that are rarely queried or have only a few possible values. Master those 4 and you will diagnose more performance problem than 90% of engineers at your level. Before you go, take 30 seconds to log this in. Takeaway 1. An index is a sorted shortcut. The table holds your data, the index holds the path to find it fast. Takeaway 2. B-tree turns a scan over millions into walk down 3 or 4 levels. That's where the speed comes from. Takeaway 3. Indexes are not free. Every one you add slow down writes. Pick the column that matters, skip the rest. In the next video, we are going to talk about transactions, ACID, what those 4 letters really mean in practice and why you really do want them when money is moving around. If this helped you, hit subscribe so you don't miss the next one. The full playlist is in the link below. See you in the next video.